students and welcome to the KVPY Sprint series. Today is lecture 3 and out of 4. So today is the penultimate lecture. Today I am going to bring some questions in inorganic chemistry. तो मैं आज ज़्यादातर inorganic chemistry से डील करूँगा. तो हम कुछ questions देखेंगे from varied amount of topics which will serve as a quick revision before the exam on Sunday. ठीक है? तो try to solve the questions with me. कुछ क्वेश्चंस फैक्ट बेस्ड हैं, कुछ क्वेश्चंस काफी अंडरस्टैंडिंग बेस्ड हैं एंड वी विल ट्राई टू फाइंड आउट द क्रक्स ऑफ इट कि क्या चीजें हमें याद रखनी है, क्या चीजें हम सोच सकते हैं. तो लेट्स सॉल्व. तो ये है पहला क्वेश्चन एंड इट इज बेस्ड ऑन केमिकल बॉन्डिंग. अब ये एक टिपिकल काइंड ऑफ क्वेश्चन है जिसमें हमें नॉलेज भी चाहिए एंड वी हैव टू देन यूज दैट नॉलेज टू गेट एट द आंसर. द क्वेश्चन इज नॉट डायरेक्ट. द क्वेश्चन इज Which one has the largest bond angle? ठीक है, तो हमें 4 मॉलिक्यूल्स दिए गए हैं. तो पहली चीज तो हमें चारों मॉलिक्यूल्स के स्ट्रक्चर पता होने चाहिए. तो बाय दिस टाइम इट इज वेरी इंपॉर्टेंट कि कुछ स्टैंडर्ड मॉलिक्यूल्स के स्ट्रक्चर्स हमें जितना इजीली याद है, मतलब सो दैट वी कैन ब्रिंग देम अबाउट. हमें सॉल्व करने की जरूरत नहीं पड़नी चाहिए. तो ये काफी कॉमन मॉलिक्यूल्स हैं. लेट्स गो देम वन बाय वन. तो मैं नीचे से स्टार्ट करूंगा. अब SO3 एंड BCl3 ये दोनों काफी कॉमन स्ट्रक्चर्स हैं. दीज आर, मैं इकट्ठा क्यों ले रहा हूं, दीज आर sp2. तो SO3 का स्ट्रक्चर होता है सिंपल. BF3 BCl3 इज और any BX3 इज अगेन लाइक दिस. इसमें खास बात क्या है, ये रेगुलर स्ट्रक्चर्स हैं. दे आर रेगुलर and these bond angles are exactly 120. तो इनकी वैल्यू हमें पता है. ठीक है, तो ये हमारा बेंचमार्क बन गया. ये भी 120 है, दिस इज ऑल्सो 120. ओके, तो अब हम बाकी दोनों देखते हैं. These are pretty simple. So these are two structures you guys should try and remember. ठीक है, sp2 trigonal planar bond angle is 120. Now what about ClF3? ClF3 is a very interesting molecule. इसमें हाइब्रिडाइजेशन क्या होता है, अगर हाइब्रिडाइजेशन निकाला जाए तो इट विल कम आउट टू बी sp3d. so it has 3 bond pairs, 2 lone pairs. Cl has 7 electrons. How to calculate it? Cl has 7 electrons. 3 electrons will be used in bonding with fluorine. So 4 are left. So those are 2 lone pairs. So 2 lone pairs, 3 bond pairs. और इसका शेप होता है T shaped. ओके, अब टी शेप स्ट्रक्चर कैसे बनता है, Cl F, 2 लोन पेयर्स हमारे इक्विलेटरल प्लेन पे होंगे. अब 2 F वर्टिकल बॉन्ड्स होंगे. 1 F लाइक दिस एंड 1 F लाइक दिस. ठीक है, सो दिस इज टी शेप. अब as you can see, this molecule is also planar, and this is also an important property which you should remember. T-shaped molecules are usually planar. So basically this atom is horizontal, this is vertical, but they are all in one plane. The lone pairs are like this. One is coming out of plane and one is going inside the plane, and they are in the horizontal plane. ठीक है, अब इसमें what is the largest bond angle? So this bond angle is obviously less than 90 degree. Okay, and the important thing is this bond angle, the FCl-F bond angle, this is obviously greater than 180 degree. ठीक है, this is not exactly 180 because these F are actually bent towards this, so they are not perfectly vertical. So if this is one F bond and this is one F bond and this is the other F, so one is tilted slightly this side, others is also tilted slightly this side. Okay, these are like this. So this is a structure. So this is greater than 180. So this is obviously much more than 120. So this is our correct answer. Okay, because there are very few molecules in which you will get a bond angle of greater than 180. So this is ClF3. Last is POCl3. Let's also do POCl3. So POCl3 is sp3 tetrahedral. It is like phosphoric acid. I'll show you how. So try to remember it like this. So instead of 3 OH groups, it has 3 Cl groups. This is POCl3, this is called phosphoryl chloride. Now, since it is sp3, the bond angles are approximately 109 degrees, but this is slightly greater because of the double bond, and this is slightly less. There is no need to remember the exact values. Because of the double bond and greater repulsion, VSEPR theory, this bond angle will be slightly greater than 109, this will be slightly less, but it is obviously the smallest out of it. So answer is ClF3. अगर इसमें smallest पूछा जाता तो what should be the answer? Smallest का आंसर भी ClF3 ही होता. क्यों? क्योंकि ये bond angle smallest है. तो ClF3 also has the largest bond angle, also has the smallest bond angle. This is overall a very interesting structure. I will encourage everybody to remember ClF3. So you can directly think about कि T-shaped structures कैसे होते हैं. एक bond angle बहुत ज़्यादा बड़ा होता है, बाकी दो छोटे होते हैं. ठीक है? So this is our first question. So let's go to the next one. Next. So now we go on to some inorganic questions. Reactions, properties of elements. So read this question. So here we are talking about white phosphorus. These are all miscellaneous questions, not related to any one chapter. General things. So white phosphorus is what? The white phosphorus is a reactive phosphorus species. It is also called yellow phosphorus. It is reactive and its structure is like this. It is a tetrahedron. Doesn't really matter, but again. So we have a tetrahedron forming 4 corners with the phosphorus atoms. This is white phosphorus. This is also an important information about phosphorus. Okay, so now the question is, when it catches fire, it produces white fumes. So when it will catch fire, whenever something catches fire, what happens? It burns with oxygen. Right? When it burns with oxygen, obviously oxide is formed. And if we use this much common sense, we can arrive at this answer. The only oxide in the options is P4O10. All the other 3 options are not oxides. So these cannot be the answer. So you can use such common sense when you are applying for answers. Again, so what happens? The compound formed is P4O10. It is phosphorus pentoxide and the structure is this. It is also a tetrahedral structure. And this is also an important structure to remember. So we have 4 phosphorus atoms. Okay, and every phosphorus is sp3 and it is bonded to a double bond O and 3 oxygen each. So every phosphorus also forms a tetrahedron and 4 tetrahedrons are joined together, and that is why this molecule is called P4O10. It is called phosphorus pentoxide, so we simplify it and also write it like P2O5. An interesting thing is, there is no molecule such as P2O5 which exists. There is nothing called P2O5. P2O5 is just a short, simple form of P4O10 used to write chemical equations. The actual physical molecule which exists is P4O10, and this forms dense white fumes. Okay, so when phosphorus burns, P4O10 is formed. So one more interesting thing, let me connect it to the other species here. So what is the oxidation state of phosphorus in this compound? So if you try to calculate the oxidation state, what will it be? So it will be +5. How did I get it? So phosphorus has 5 bonds, 1, 2, 3, 4, 5, right? Each phosphorus has 1, 2, 3, 4, 5 bonds, and the bonds are with more electronegative atoms. So for each bond it gets an oxidation state of +1. So oxidation state is +5. Okay, so it is a oxide of phosphorus with an oxidation state +5. Now why is that important? So one more thing which is important about P4O10 is simple thing. If we hydrolyze it or dissolve it in water, so this is an acidic oxide. So phosphorus is a non-metal, it forms an acidic oxide. So when you dissolve it in water, you get an acid. So what acid will you get? So now to predict that, we can use a simple thing. The oxidation state of phosphorus will remain the same. So whenever you put an oxide in water, a simple oxide, it forms an acid, an acidic oxide forms an acid, and mostly what happens is you get an acid with the same oxidation state. So what should be the oxidation state of acid? +5. So acid form will be phosphoric acid. So each one molecule will give you 4 units of phosphoric acid. So that can also be asked if dense white fumes are formed and when they are dissolved in water, they form an acidic solution, and that acidic solution is phosphoric acid. So if you pay some attention, how is that happening? So basically for each phosphorus unit, this bond is broken, this bond is broken, and this bond is broken. So this unit separates and you can see P double bond O, PO, PO, PO. So it just attaches and you get phosphoric acid. And similar thing happens with all 4. So white phosphorus burns in air, gets pentoxide, which is P4O10. When it hydrolyzes, you get phosphoric acid, S3PO4. And the common link between them is the same oxidation state. Okay, so this is enough information about phosphorus. Any of the above things can be asked. You can be asked the hybridization, you can be asked anything. Chalo, next question. Now this is a very common and very important property of carbon dioxide. I would like you guys to go through it, and I bet many of you would have heard about this experiment. So what does it say? This is a very famous experiment about CO2. Now after it I'll get to a very interesting fact about this statement. So let's start. So we have CO2 gas. So the entire question is about a test, a real laboratory test which is created to detect CO2, and this will come in very handy later as well. So CO2, let me draw a diagram. CO2 is passed through lime water. So you must also know what is lime water. So can you guys try and remember what is lime water? So lime water is simply a solution of calcium hydroxide. Calcium hydroxide aqueous solution is called lime water. So what do we do is, we take a beaker, we have an aqueous solution of calcium hydroxide, clear solution, and we pass CO2 gas in it. Then what happens? This turns milky. To milkiness, I'll draw it like this. And what does milky mean? So try and imagine you have a glass of water and it slowly turns into milk. So milk is, it becomes translucent. This is transparent, it becomes transparent. White, translucent thing. So it's called milky. And this is a very famous test. So why does it turn milky? So the reaction involved here is, this is a base, CO2 is an acidic oxide, right? So whenever an acidic oxide reacts with a base, I can give you more examples, but CO2 is the most important. So whenever an acidic oxide reacts with a base, any base, calcium hydroxide, sodium hydroxide, any hydroxide which is a strong base, its salt will be formed. Okay, whenever base and an acidic oxide react, salts are formed. Now CO2 will form what salt? Carbonate salt. So here it forms milky due to formation of calcium carbonate. Calcium carbonate is insoluble in water, and due to which it forms milkiness. So this is the first part of the experiment. Everybody should know this. This is a very important topic. So CO2 and pass through calcium hydroxide will give you a milky solution. So again, what is to be remembered here? First of all, an acidic oxide reacts with a base, you will get a salt. Now, if it will turn milky or not, if the salt is insoluble, then obviously it will give a precipitate, and in this case it gives a milkiness, and then some time afterwards it will settle down and give a precipitate. Okay, but if that salt is soluble, then nothing will be observed. It will remain a solution. So that is why we do the test with calcium hydroxide, because calcium carbonate is not soluble. ठीक है, अगर यही test, if the same test was conducted with sodium hydroxide, then what is formed? Sodium carbonate is formed. Sodium carbonate is soluble in water, so you will get no milkiness. Okay, this is understood. So this is part 1. Now what happens? So turns milky and then becomes clear upon continued bubbling of CO2. Now this is the second part of the test. Now what you do is, if you keep pumping in CO2, so if more CO2 is put into this solution, so first of all it will turn milky. Then if you will keep on adding CO2, keep on adding CO2, keep stirring, then it will turn clear again. This is again a clear solution. So on adding more CO2, the solution again will become transparent and it will become clear. Now why does that happen? And that happens because sodium carbonate, which was already calcium carbonate, which was already in the solution, reacts with CO2 again and forms calcium bicarbonate. This is called calcium bicarbonate. So calcium carbonate again reacts with CO2 and water present in the solution to get calcium bicarbonate. This is the end of the reaction. So now calcium bicarbonate is soluble. So when this is formed, when calcium carbonate is converted back to calcium bicarbonate, the solution becomes transparent. Okay, so this is a test. So we have a solution, CO2 is passed, it becomes milky, and more CO2 is passed, it becomes transparent again. So this is a famous test for CO2, and this is the chemistry behind it. So our answer to the question is D. I can also write the chemical equation for you guys. So calcium carbonate plus CO2 plus water will form calcium bicarbonate, and which is soluble. This is an important thing. Not only the reaction, when the substance is formed, milkiness will depend on whether the substance is soluble or not. So this is soluble, so no milkiness. Okay, now two interesting facts about this. Further on, add-ons. So one very interesting fact is, all bicarbonates, all from group 1, sodium, lithium, potassium, anything, calcium, barium, any bicarbonate is always soluble. So in the world of chemistry, when you have to learn a lot of things, kaun sa soluble hai, kaun sa nahi hai, kaun sa colored hai, kaun sa nahi hai, there are so many things to learn. So there are some constant things which you can learn and which will help you all the 2 years. So two things are like that. So all bicarbonates are soluble. So there cannot be a bicarbonate which is not soluble. Okay, that makes learning things easier when you can form a generalized statement. Another statement, similar statement, is about nitrates, which is not related to this question, but I will still tell you, all nitrates, any salt which is a nitrate is also always soluble in water. No nitrate can ever be a precipitate. Okay, so these are two facts. One more thing. Okay, we are done with the question. So this is the test. Same test, you can also write it down and keep it in your notes, and this is gonna help you all throughout next year. This is also Arjun's colloidal analysis in the +2 syllabus. One more gas which is not CO2 also give the same test. So, and what is that gas? That gas is SO2. SO2 gas also gives an exact same test when passed through lime water. So if you replace CO2 with SO2, you will have the same observations. You will pass SO2 through lime water, it will give you a milkiness. Then more SO2 will be passed, you will get a clear solution. And what are the compounds found? Instead of calcium carbonate, instead of carbon, you will have sulfur. You will form CaSO3, calcium sulfite, which is again insoluble, and you will get calcium HSO3 bisulfite, which is soluble. So one other important fact to remember here is SO2 also gives the same test. So sometimes in the similar question, a question can be asked, a gas X turns lime water milky and it becomes clear after excess of gases pass through the solution. What can be the gas X? So then the answer can be CO2 as well as SO2. Sometimes CO2 will not be in the options and you will have to mark SO2. So these are the two gases which give the same exact test. Okay, so these three things are important related to this question. चलो आगे चलते हैं. यहाँ पे हम काफी चीजें सीख गए. तो आंसर इज डी. So now we come to a numerical which is also similarly inorganic based. So I guess you guys can try and solve this question. Again, we have to come up with the reaction ourselves, then solve it using stoichiometry. So let's do it. Again, reminding you, these are all previous year questions. Every one of them has been previously asked in the KVPY exam. So what do we have here? हमारे पास कुछ कैल्शियम है, ठीक है. एटॉमिक मास तो हमें पता है 40. अगेन एक छोटा सा डाउट जो हमेशा बच्चे पूछते हैं एग्जाम्स में, जनरली एटॉमिक मास वैल्यूज, कांस्टेंट की वैल्यूज लाइक आर हो गया, राइट वर्क कांस्टेंट हो गया, सब गिवन होती हैं. तो उसकी बहुत टेंशन लेने की जरूरत नहीं है कि हमें याद नहीं है. तो एटॉमिक मास वैल्यूज एंड कांस्टेंट वैल्यूज आर ऑलवेज गिवन, ठीक है. डिसॉल्व्स कंप्लीटली इन एसिड. अब अगेन देखो, एक बहुत सिंपल चीज है. अगर कोई भी मेटल, और हमने कल बात की थी, एक एसिड में रिएक्ट करता है तो क्या होता है? तो बहुत सारी चीजें हो सकती हैं, लेकिन एक बहुत कॉमन, दिस इज अ वेरी जनरल रिएक्शन, हाइड्रोजन गैस इज रिलीज्ड मोस्टली. एंड फॉर व्हाट मेटल्स? तो दिस इज ट्रू फॉर एनी मेटल above hydrogen in the reactivity series. और हमें पता है कैल्शियम तो काफी ऊपर होता है. तो ऑल ग्रुप 1, ऑल ग्रुप 2 एलिमेंट्स डू दिस. तो कॉपर ये नहीं करता, जैसे हमने कल देखा था, कॉपर डजंट, बट मोस्ट मेटल्स डू. तो कॉपर, सिल्वर, गोल्ड, प्लेटिनम, मर्करी, ये सारे एलिमेंट्स जो हाइड्रोजन के नीचे आते हैं वो ये रिएक्शन नहीं देंगे. उसके अलावा सारे मेटल्स ये रिएक्शन देते हैं. तो हमें ये पता है. तो कैल्शियम इज अ वेरी रिएक्टिव मेटल. इट whenever a metal reacts with acid, हाइड्रोजन गैस रिलीज होती है. तभी क्वेश्चन क्या है? टू प्रोड्यूस इतना लीटर ऑफ हाइड्रोजन गैस. तो हमें अब अमाउंट ऑफ हाइड्रोजन गैस पता है और हमें बताना है कि कैल्शियम का कितना मास यूज हुआ होगा. अब इसके दो तरीके हैं. वी कैन डायरेक्टली डू इट विद स्टोइकियोमेट्री बाय राइटिंग द बैलेंस्ड इक्वेशन, ठीक है. तो मेथड 1, कैल्शियम, हम एक बैलेंस्ड इक्वेशन लिखेंगे 2HCl. अब फिर प्रोडक्ट क्या बनाएंगे? मेटल का कार्बन सॉल्ट, कैल्शियम क्लोराइड, और साथ में हाइड्रोजन. हाइड्रोजन प्रोडक्ट मुझे पता है, तो मेरे ख्याल से ये बैलेंस्ड है. ओके, सो फ्रॉम हियर व्हाट आई कैन गेट, 1 मोल कैल्शियम गिव्स यू 1 मोल हाइड्रोजन. मोल्स ऑफ हाइड्रोजन हम कैसे निकालेंगे? मोल्स ऑफ हाइड्रोजन है सिंपल, 5 पॉइंट वॉल्यूम जो भी है एसटीपी पे अपॉन 22.4, राइट. मोल्स ऑफ हाइड्रोजन इज दिस गैसियस स्टेट. अब मास ऑफ कैल्शियम कितना हो जाएगा? तो मास ऑफ कैल्शियम मोल्स इनटू 40. एक छोटी सी चीज है, ट्रिक तो क्या है, कैलकुलेशन करने के लिए कभी भी ये सॉल्व मत करो, हमेशा कीप इट इन फ्रैक्शंस. ऑलवेज ओनली ट्राई एंड सॉल्व द फाइनल आंसर एंड ट्राई एंड अप्रॉक्सीमेटेड. तो व्हाट इज दिस? 5/22 करीब करीब क्या है? 1/4.5, राइट? 22.5 होता तो करीब करीब 1/4.5. तो दिस इज 1/4.5 into 40. So 40/4.5 just less than 10. So what is less than 10? Oh, we have two answers less than 10. So we have to calculate it a little better. So this is approximately 40/4.5. 80/9. 80/9. 9 9s are 80. So answer should be approximately C. Right? So these kind of approximations can work. Okay? So this is a simple question. Again, what I wanted to teach you through this question is how can you come up with general inorganic reactions. You don't have to always mug up everything. कुछ general concepts होते हैं which will help you solve reactions. तो एक हमने किया, phosphorus का ऑक्सीजन से बना ऑक्साइड बनेगा, और ऑक्साइड पानी में डालेंगे तो एसिड बनेगा. Similarly, कोई भी मेटल एसिड से रिएक्ट करे तो हाइड्रोजन गैस रिलीज होगी. So this reaction we know. From then we can use mole concept to solve it. Simple. Now there is also another method using equivalent concept, right? Which works similarly, but it is just the same thing. So what do we say is, मैं ये हटा देता हूँ. Equivalent concept में हम क्या करते हैं? हम बस इक्वेशन नहीं लिखते और हम एक अमाउंट ऑफ डेटा याद रखते हैं. तो let's see what do we do in equivalent concept. You can do either way, whatever you like. अब equivalent concept से हम क्या करेंगे? We say amount of metal consumed. Amount मतलब equivalents. Sorry, equivalent concept. So equivalents of metal. And this is true for this general reaction. Whenever a metal reacts with acid, तो हम एक statement लिख सकते हैं equivalents of metal which reacts या consumed equal to equivalents of hydrogen gas produced. Simply we can write this. Now कैल्शियम की वैलेंसी होती है 2, तो उसका इक्विवेलेंट मास हो जाता है क्या? मॉलिक्यूलर मास बाय 2, 40. तो नंबर ऑफ इक्विवेलेंट्स कितने हो जाएंगे? x मास अपॉन इक्विवेलेंट मास. इक्विवेलेंट मास इज 20, राइट? 20 कैसे आया? 40/2, इक्विवेलेंट मास बाय 2. हाइड्रोजन के लिए हमें पता है इक्विवेलेंट मास इज ऑलवेज 1. तो बट मास इक्विवेलेंट वॉल्यूम इज 11.2. तो 1 मोल हाइड्रोजन इज 2 इक्विवेलेंट्स. ठीक है, 1 मोल हाइड्रोजन इज 2 इक्विवेलेंट्स. ये याद रखते हैं. तो मोल्स ऑफ हाइड्रोजन कितने हो गए? 5.04 अपॉन 22.4 इनटू 2, क्योंकि 1 मोल हाइड्रोजन इज 2 इक्विवेलेंट्स. और तुम आंसर देखो सेम आ गया, x इक्वल्स टू 5.5/22 इनटू 40. So this is the equivalent concept. Whenever a metal reacts with acid to form hydrogen gas, we can write equivalents of metal consumed is equal to equivalents of hydrogen gas produced. Metal के equivalent weight हम अलग से निकाल के रखेंगे. तो ये metal के equivalents हो गए, given mass by equivalent mass. Gases में hydrogen का equivalent mass होता है 1, तो यानी 1 mole gas is always 2 equivalents. Okay, 1 mole gas is always 2 equivalents. So you can also calculate the equivalents of hydrogen then directly. तो तुम equation लिखनी नहीं पड़ेगी. You don't have to use it. Same ही चीज है. There are 2 ways to say the same thing. You can know whatever you want. ठीक है, चलें आगे. तो आंसर है C. नेक्स्ट क्वेश्चन. ये अब सीधा सीधा प्रोडक्ट टेबल का क्वेश्चन है. आई गेस ये तुम लोग कर लोगे. पूछा क्या गया है, फिर भी इसमें भी मैं आ जाता हूं. तो मुझे 4 ऑक्साइड्स दिए हैं, ठीक है, और मुझे दिख रहा है ये ग्रुप 15 है. फॉस्फोरस, आर्सेनिक, एंटीमनी एंड बिस्मथ. तो ये ऊपर से नीचे एक ही ग्रुप है, जानबूझ के ये एलिमेंट्स दिए हैं. तो टॉप टू बाउंड क्या होता है? एसिडिटी ऑफ ऑक्साइड डिक्रीजेस. Acidity of oxide decreases. तो आंसर क्या हो जाएगा? तो P2O5 या P2O3, this greater than this, greater than this, greater than this. Down the group जैसे जैसे हम नीचे चलते जाते हैं एसिडिटी डिक्रीजेस. Down the group it decreases, up the group it will increase. This is a common general concept in periodic table. So answer should be A. तो जैसे जैसे नीचे जाते जाओगे तो एसिडिटी कम होती है. ओके, नेक्स्ट. Now this is a very interesting problem and property of HCl and calcium hydrochloride. It involves a lot of reactions. Read it through. And there is an error. Let me correct it first. Oops. ये HCl होगा. This is not HCl2. So this question involves two different reactions. First reaction is MnO2 reaction with HCl. So MnO2, as you might remember from redox, is an oxidizing agent. Here manganese oxidation state is +4. This is an oxidizing agent. Just keep it in your back of the mind. And there is a very important reaction for MnO2. When it is treated with HCl gas, it oxidizes HCl gas. Okay. So chloride here is in -1 oxidation state. It oxidizes HCl gas to give you. So when chloride is oxidized, chlorine gas is produced. So this is the first reaction. And why is this reaction important? Because this is a laboratory preparation of chlorine. तो अगर लेबोरेटरी में मुझे क्लोरीन गैस प्रिपेयर करनी है, this is one of the best methods. MnO2 when reacts with HCl gives you chlorine gas. So this is the first reaction. The gas access chlorine, and this is a redox reaction. MnO2 is oxidizing HCl to form chlorine. Okay, you can balance the rest of the reaction. I'll complete it. So manganese is reduced to +2. So MnCl2 is formed, and hydrogen will be consumed in some water. So I'll get some water. So it's a good exercise. Try and balance out this reaction. That's for your homework. You can use the oxidation number method. Let me help you. N factor इसका कितना होगा? इसका N factor 2 होगा ना? 4 से 2 गया. MnO2 का oxidation state of manganese has changed from +4 to +2. So N factor is 2 and N factor of HCl is 1 because -1 to 0. So balance कर लोगे कैसे? Cross. इसका N factor है 1. ये हो जाएगा 2. Rest you can easily do it. Okay. To balance it out. So this is the first reaction. Try and remember this. MnO2 reacts with hydrochloric acid to give you chlorine gas. Now we move on to the second part of the problem. Now it says gas X reacts with calcium hydroxide, and this is called slaked lime. So now chlorine gas, when passed through a solid, and this solid is calcium hydroxide, and this is a very famous reaction, and mostly you will also see the name slaked lime. Slaked lime is the name of solid calcium hydroxide. So when chlorine gas is passed over solid calcium hydroxide, a disproportionation happens and bleaching powder is formed. And what is bleaching powder? Calcium chloride and then OCl ion is formed. So this is bleaching powder. So this is the preparation of bleaching powder. So when chlorine gas reacts with slaked lime, disproportionation happens. So why it is called a disproportionation? Because chlorine oxidation state is 0. In this compound, this Cl negative, this is a Cl negative ion, and this is a OCl negative ion. So calcium is +2, this is -1, this is -1, but oxidation state of this chlorine atom is +1, and oxidation state of this chlorine atom is -1. So chlorine is being reduced and chlorine is being oxidized at the same reaction. So this is a disproportionation which happens with alkali. Okay, so these two are again very important reactions to remember. One is the preparation of chlorine gas, one is the preparation of bleaching powder. You might have heard of both of these compounds. So answer is C, bleaching powder. Next, now this is a heating effect of oxalic acid. Oxalic acid ये थोड़ा बहुत ऑर्गेनिक में चला जाता है, but this is also very relevant in inorganic chemistry. Oxalic acid क्या होता है? Oxalic acid is this carbon, okay. एसिड ग्रुप ऑर्गेनिक में क्या होता है? ये ग्रुप होता है कार्बोक्सिलिक एसिड ग्रुप, CO2H ग्रुप. दो CO2H ग्रुप अगर इकट्ठे लग गए आपस में तो दिस इज ऑक्सैलिक एसिड. अब इसकी एक बहुत पेक्यूलियर प्रॉपर्टी है, जब इसको हम कंसंट्रेटेड H2SO4 में मिक्स करके हीट करते हैं, दिस डीकंपोजेस. ठीक है. अब कंसंट्रेटेड H2SO4 का जनरल आइडिया क्या है? इट एब्जॉर्ब्स वाटर. तो जो हाइड्रोजन और ऑक्सीजन है ये वाटर में, वाटर तो वो एब्जॉर्ब कर लेता है, तो दिस एब्जॉर्ब्स वाटर. अगर इसने वाटर एब्जॉर्ब कर लिया तो बचा क्या? कार्बन और ऑक्सीजन. तो दो गैसेस रिलीज होती हैं, CO गैस एंड CO2 गैस. तो वी हैव टू कार्बन्स हियर, 1:1 रेशियो. तो हमेशा एक ऑक्सैलिक एसिड मॉलिक्यूल से एक CO मॉलिक्यूल बनता है, एक CO2 मॉलिक्यूल बनता है. ठीक है. प्लस एक वाटर मॉलिक्यूल होना चाहिए अगर तुम बैलेंस करोगे तो, एंड दिस इज एब्जॉर्ब्ड बाय द एसिड. तो इसलिए वो प्रोडक्ट्स में नहीं लेगा. तो क्वेश्चन इज व्हाट आर द मेजर प्रोडक्ट्स ऑब्टेन्ड? तो मेजर प्रोडक्ट्स ऑब्टेन्ड आर CO एंड CO2. Water remains in the mixture. ठीक है. तो आंसर इज कार्बन डाइऑक्साइड एंड CO. तो आंसर इज C. ठीक है. ऐसा एक बहुत सिमिलर रिएक्शन है जो भी मैं यहां पे बता देता हूं, जो कि इसके साथ ही याद रख लो तो अच्छा है. अगर ये ऑक्सैलिक एसिड का रिएक्शन हुआ तो एक और एसिड जो काफी कॉमन है उसको हम कहते हैं फॉर्मिक एसिड. दिस इज फॉर्मिक एसिड. ये तो सबको पता होगा, सबने देखा होगा. इसको भी अगर एक सिमिलर रिएक्शन से पुट थ्रू किया जाए, कंसंट्रेटेड H2SO4, तो अगेन सेम चीज होती है, वाटर इज एब्जॉर्ब्ड, यू गेट CO गैस ओनली प्लस वाटर, एंड दैट वाटर इज आल्सो एब्जॉर्ब्ड बाय द कंसंट्रेटेड H2SO4. तो फॉर्मिक एसिड ओनली गिव्स यू कार्बन मोनोऑक्साइड, ऑक्सैलिक एसिड गिव्स यू बोथ कार्बन मोनोऑक्साइड एंड कार्बन dioxide. This is the heating effect of formic acid and oxalic acid in concentrated acid. ठीक है. You will do well to remember these two. चलो आगे चलें. Next question. So this is a pretty simple one, but again a very important one. I hope अब तक सबने ये क्वेश्चन कभी ना कभी देखा होगा. तो we'll again go through this quickly. डायामैग्नेटिक स्पीशीज. तो डायामैग्नेटिक क्या होता है? नो अनपेयर्ड इलेक्ट्रॉन्स. है ना. अब लोग इसमें एक बहुत कई मैंने स्टूडेंट्स देखे हैं, दे गो थ्रू अ वेरी सिंपल डिलेमा, क्योंकि व्हेन यू आर टॉट इन द फर्स्ट चैप्टर यू, आई लेट मी गो थ्रू अ स्टोरी, और अगर ये भी तुम्हारे साथ हुआ है तो पे अटेंशन. होता क्या है, द फर्स्ट टाइम जब तुम लोग क्लास 11th में आते हो, द फर्स्ट चैप्टर यू स्टडी इज एटॉमिक स्ट्रक्चर, राइट? एंड द फर्स्ट टाइम व्हेन दिस टर्म डायमैग्नेटिक एंड पैरामैग्नेटिक कम्स इज इन MOT theory. You are taught MOT theory. There you are taught to draw structures. There you are taught to count unpaired electrons. ठीक है, केमिकल बॉन्डिंग, नॉट atomic structure, I'm sorry. अब क्या होता है? So whenever, for many students what happens is, whenever they see a molecule is diamagnetic, paramagnetic, they try to use MOT theory. That is not correct. MOT theory which we study is only for homonuclear diatomic species. It is a very, very limited theory which you study. Technically it can be done for anything, but we are not advanced enough to use it for other molecules. तो उन molecules के लिए हम नहीं पढ़ते, ठीक है. तो लोग confuse हो जाते हैं कि NO2 का क्या करें. तो how can we calculate? How can we calculate for CO2? How can we calculate for this? So you are actually not supposed to use it. Many people ask me this doubt. That is why I am clarifying here. So what you are supposed to do is, for all the molecules for where you can use the MOT theory, like O2. Now O2 is a very, very important example for diamagnetic paramagnetic, because in MOT theory, this is the first time we find out that this has two unpaired electrons, and this can only be explained through MOT theory. So this can only be explained through MOT theory. So this is good. But for these molecules, this is diatomic but not homonuclear, and these are triatomic. We cannot use MOT theory, and we are not supposed to. तो इनके लिए क्या करना है? Simply draw their structures, okay? And don't even draw their structures. Just count the number of total electrons. So here the total number of electrons is, oxygen has 8, that 15 electrons. Here the total number of electrons is what? 15 plus 8, 23 electrons. Here we have 8 and 8, 16 plus 6, 22 electrons. We don't even care. Because we cannot use MOT theory, the only thing we do is, if the number of electrons is odd, and total electrons, not even unpaired, if the total number of electrons are odd, then obviously there is one unpaired electron. At least one. We don't have to count the number of unpaired. At least. ये तो बहुत obvious है ना. तो ये तो diamagnetic हो ही नहीं सकते. Total electrons तो we can always count without even knowing the structure. If the total number of electrons are odd, then the species has to be paramagnetic. Okay, so this is paramagnetic, this is paramagnetic, and this is paramagnetic. Here the total number of electrons is 16. And if we didn't know MOT theory, अगर हमें MOT theory नहीं पता होती, तो हम यहाँ भी prediction नहीं कर सकते थे. तो MOT theory का ये एक बहुत बड़ा advantage है और success है कि it can successfully explain the paramagnetic character of oxygen despite having even electrons. But you don't have to do this for other molecules. For bigger molecules, you just have to count the number of electrons. अगर वो odd है तो वो paramagnetic हो गए. अगर वो even है, तो we just say they are diamagnetic. So this is all we have to do. ठीक है? I guess confusion doubt खत्म हो गया होगा. तो you are not supposed to draw the MOT diagram for CO2 जो हम बना भी नहीं सकते. ठीक है? तो this is how you are supposed to solve it. So D is diamagnetic, rest are all paramagnetic. So to find out paramagnetism, there are two ways. If it is a molecule for which you have studied in MOT, like O2 and B2, then you have to use the MOT. For all others, you just have to count the number of total electrons. If they are odd, it is paramagnetic. If they are even, it is diamagnetic. I hope it is clear. So these questions are very simple and they are very commonly asked. So this is the paramagnetism. So let's go on to the next one. Again, a very common question, and this has been included by me to explain a very simple concept, which is very general. Again, my theme for today is how we can think about inorganic chemistry. It's not always about learning. You can also make very important patterns. Now what is this? This is a very common question, and it deals with something which is called amphoteric character. Amphoteric character सबने सुना होगा और कई लोगों के लिए it is slightly confusing. I'll try to solve the confusion today. So let's deal with the question first. So it talks about Al2O3. So Al2O3 के बारे में हम क्या जानते हैं? तो Al2O3 is an oxide of a metal, aluminium, right? तो हमें छोटी क्लासों में, छोटी नहीं जूनियर क्लास में क्या पढ़ा गया? मेटल ऑक्साइड्स दो तरह के होते हैं. वैसे ऑक्साइड जनरली 3 तरह के होते हैं. आइदर दे आर एसिडिक और दे आर बेसिक और दे आर न्यूट्रल. ठीक है? और हम वी टेंड टू बिलीव ऑलवेज बचपन में कि यार कोई चीज या तो एसिडिक होगी या तो बेसिक होगी. ठीक है? तो प्लीज फॉरगिव माय वेज. आई एम जस्ट ट्राइंग टू मेक इट a little interesting so that you pay attention here, and this is a very important concept and many people are confused about this. So बचपन से हमने देखा एसिडिक ऑक्साइड्स कैसे होते हैं, CO2, SO2। तो नॉन मेटल के ऑक्साइड्स जनरली एसिडिक हो जाते हैं, और बेसिक ऑक्साइड्स कौन से होते हैं, सोडियम के, पोटेशियम के, कैल्शियम के। मेटल के जो ऑक्साइड्स होते हैं जनरली बेसिक होते हैं। तो यहां तक हमारी नॉलेज है। अब जैसे हम थोड़ा आगे चलते हैं, सिचुएशन इज नॉट दैट सिंपल एक्चुअली। ये 0 और 1 बाइनरी सिचुएशन नहीं है। तो देयर इज समथिंग कॉल्ड एसिडिक और बेसिक कैरेक्टर। कोई चीज एकदम एक एक्सट्रीम पे एसिडिक हो सकती है, कोई चीज एक एक्सट्रीम पे बेसिक हो सकती है। अब कई सारी चीजें बीच में कहीं लाया करती हैं, वो ना कंप्लीटली एसिडिक है ना कंप्लीटली बेसिक है, तो जो कहीं बीच में आती हैं। ठीक है, तो हम ऐसे एलिमेंट्स की बात करेंगे, और ऐसा एक एलिमेंट है एल्यूमिनियम, और इस ऑक्साइड को हम बोलते हैं एम्फोटेरिक। तो व्हाट डज एम्फोटेरिक मीन? तो व्हाट डज एम्फोटेरिक मीन का मतलब एक्चुअली इससे आएगा कि व्हाट डज एसिडिक एंड बेसिक मीन। एसिडिक मीन्स विच रिएक्ट्स विद बेस या विद एल्कली। जैसे कि आज हमने क्या देखा, CO2 एसिडिक ऑक्साइड है। क्यों? क्योंकि वो NaOH या कैल्शियम हाइड्रोक्साइड जो एल्कलाइन बेसिस हैं उनसे रिएक्ट करती है। बेसिक क्या होता है? विच रिएक्ट्स विद एसिड्स। कैल्शियम ऑक्साइड बेसिक ऑक्साइड है। क्यों? वो HCl से रिएक्ट करेगी, वो एसिड से रिएक्ट करेगी, वो एल्कली से नहीं करेगी। एम्फोटेरिक क्या होता है? रिएक्ट्स विद बोथ एसिड्स एंड बेसिस। Reacts with both acids and bases. That is the simplest technical meaning of amphoteric. अब कई लोग सोच रहे होंगे न्यूट्रल क्या होता है। न्यूट्रल में भी बहुत, न्यूट्रल और एम्फोटेरिक में फर्क है। न्यूट्रल इज रिएक्ट्स विद नन, दोनों से ही नहीं करती। इसका एक बहुत अच्छा एग्जांपल है CO। CO एक कार्बन का ऑक्साइड है जो कि ना एल्कली से रिएक्ट करता है ना एसिड से करता है। दिस इज न्यूट्रल। तो न्यूट्रल गेम में आएगा ही नहीं, न्यूट्रल वी आर नॉट टॉकिंग अबाउट। तो देयर आर सम ऑक्साइड्स व्हिच लाई बिटवीन एसिडिक एंड बेसिक एंड दे रिएक्ट विद बोथ एसिड्स and bases, and they are called amphoteric, and the one of the best examples for such an oxide is aluminium. ठीक है, अब बाकी examples क्या है? तो you should also remember some more examples of amphoteric oxides. So they are aluminium, zinc. Zinc is a very important example. Zinc with its oxide, zinc oxide. This is an amphoteric oxide. ठीक है. Secondly, tin. Tin is amphoteric. SNO. So these three elements are very amphoteric. So you should try and remember these. Aluminium, zinc are the most important, and tin is also amphoteric. One more is lead. So lead with its oxide PbO is also amphoteric. So you should try and remember these elements: aluminium, zinc, tin, lead. These are elements which lie in somewhere in middle of metals and non-metals in terms of their acid-base properties. They react with both acids and bases. अब मैं एक सिंपल सा एग्जांपल देता हूँ। अब सोडियम में, सोडियम won't react with NaOH, है ना? सोडियम won't react with NaOH. सोडियम will react with acid. ठीक है? सोडियम एक बेसिक मेटल है। अब इन एलिमेंट्स की प्रॉपर्टी क्या है? इन सारे एलिमेंट्स में अगर मैं HCl ऐड करूं तो भी हाइड्रोजन गैस मिलेगी। ये एक और प्रॉपर्टी होती है एम्फोटेरिक एलिमेंट्स की जो कि काम की है। इसमें मैं NaOH ऐड करूं तो भी हाइड्रोजन गैस मिलेगी। तो देयर इज वन मोर इंपॉर्टेंट प्रॉपर्टी ऑफ एम्फोटेरिक कंपाउंड, एम्फोटेरिक मेटल्स। हमने अभी क्या देखा था? मेटल्स जनरली एसिड्स के साथ रिएक्ट करके हाइड्रोजन गैस रिलीज करते हैं, तो ये सारे करेंगे। ठीक है, ये भी। अब इनकी दूसरी प्रॉपर्टी क्या है? ये बेसिस के साथ या एल्कली के साथ, NaOH के साथ भी रिएक्ट करके हाइड्रोजन गैस रिलीज करेंगे। जो सिंपली बेसिक मेटल्स हैं, सोडियम, पोटेशियम, कैल्शियम, मैग्नीशियम, बेरियम, वो ये नहीं करते। दे डोंट रिएक्ट विद NaOH टू फॉर्म हाइड्रोजन। तो दिस इज द सेकंड मोस्ट इंपॉर्टेंट प्रॉपर्टी फॉर दीज एलिमेंट्स। तो व्हाट आर द टू थिंग्स? एम्फोटेरिक मेटल्स होते हैं, दे रिलीज हाइड्रोजन फ्रॉम एसिड्स एज वेल एज बेसिस, दैट इज एन इंपॉर्टेंट प्रॉपर्टी। सेकेंडली, उनके ऑक्साइड्स ऑल्सो रिएक्ट विद बोथ एसिड्स एंड बेसिस टू फॉर्म सॉल्ट्स। ओके, so these are amphoteric and you have to try and remember them. So this is a simple short primer about amphoterism. ओके, तो दिस ऑल्सो कंफ्यूजेस मेनी पीपल। तो यहां से हम एक सिंपल चीज सोचते हैं, जरूरी नहीं है हर ऑक्साइड या एसिडिक हो या बेसिक हो। तो एम्फोटेरिज्म मींस एक तरह से वो ऑक्साइड एसिडिक भी है अगर उसको बेस से रिएक्ट करा दिया जाए, और वो ऑक्साइड बेसिक भी है अगर उसको एसिड से रिएक्ट करा जाए, और ऐसे ऑक्साइड्स को हम एम्फोट्रिक कहते हैं, और जो एलिमेंट्स ऐसे ऑक्साइड बनाते हैं वो एलिमेंट्स एम्फोट्रिक एलिमेंट्स होते हैं। ठीक है, आई होप दिस सॉल्व्स द सिचुएशन एंड मेक्स इट अ लिटिल मोर क्लियरर as you will advance further in next year, you will study completely P block. These concepts will come in a lot handy. This is also a general concept in inorganic chemistry which should be understood. Okay, so let's go on to the next question. Again, this is again a very interesting question, and also it involves a very general concept about acid base and ammonia. So this question is about preparation of ammonia. So ammonia we all know, NH3. And ammonia preparation has a very general reaction, and which everybody should know, and this is one of the most important reactions in inorganic chemistry. And this is a simple acid base reaction. So what is the reaction? Let's go. So if I have any ammonium salt, it doesn't matter what the anion is. So I have an ammonium and it has an X anion with it. I don't care what the anion is. Okay, so any ammonium salt, when it is treated with an alkali, NaOH, and NaOH should not be written, any alkali, OH negative is important thing, any alkali. This is the general thing. So whenever any ammonium salt is treated with an alkali, ammonia gas is produced. This is a very important reaction, very important concept. General, doesn't matter what the salt is, doesn't matter what the alkali is. So now if you'll use this concept, I'll also explain why this happens. Let's use this concept to solve the question. Ammonium salt, alkali. What will be formed? Ammonia. So this gives us ammonia. Can you see another one? Here. Ammonium salt, alkali. Again, I know you will get ammonia. So these both will give you ammonia. Okay? Again, this is a very important concept, and this is used in qualitative analysis. This is a very important, and it will be repeated again and again. You will see. So this is a general thing you should try and remember. Now, why does it happen? ये एक simple acid base reaction है. अगर मैं ammonium बनाऊं, ammonium is this, right? NH4. We can explain it on the basis of bonding. This is NH4 plus. This is an acid. Basically, this is a proton donor. इसके पास एक extra proton है. ये एक base है. This is a proton acceptor. So simply what happens? It accepts its proton. क्या बन जाएगा? Water अलग और अमोनिया अलग. तो बस ये रिएक्शन देखने में शुरू में काफी कॉम्प्लिकेटेड है, कौन सा सॉल्ट और ये उससे अमोनिया बन रही है. सिंपली ये हो रहा है, एक अमोनियम एक प्रोटॉन डोनर है, वो OH नेगेटिव प्रोटॉन दे देता है, तो अमोनिया गैस रिलीज हो जाती है. एंड बिकॉज अमोनिया इज अ गैस, इट इज रिलीज फ्रॉम द सॉल्यूशन. सो आई होप यू अंडरस्टैंड दिस. दिस इज अ सिंपल एसिड बेस रिएक्शन. तो ये कंसेप्ट से हमारे दो ऑप्शन सॉल्व हो गए. सो दिस इज वन मेथड ऑफ फॉर्मिंग अमोनिया. नाउ लेट अस गो टू द नेक्स्ट मेथड. ठीक है, रेडी? तो हमारा ऑप्शन ए और डी तो कैंसिल हो गया, तो मैं हटा दूं. तो नाउ आई गोइंग टू टॉक अबाउट अ सेकंड जनरल रिएक्शन टू गिव अमोनिया. ओके, तो सेकंड जनरल रिएक्शन इज नाइट्राइड्स. What are nitrides? Nitrides are salts which have the N3 negative ion. Examples: aluminum nitride, magnesium nitride, calcium nitride. In some cases we can also talk about lithium nitride. ये चार नाइट्राइड्स की अगर मैं बात करूं, इनमें कॉमन चीजें क्या है देखने के लिए तो ये 4 अलग अलग कंपाउंड्स हैं. व्हाट इज कॉमन? द कॉमन थिंग इज दे ऑल हैव द N3 नेगेटिव आयन. ठीक है, so that is an important thing. So it doesn't matter what the cation is, only N3 negative matters. Whenever you will put it in water, hydrolysis, this is called hydrolysis. That doesn't actually mean anything, that's just a name. Hydrolysis simply means breaking by water. So whenever these are hydrolyzed, N3 negative will accept 3 protons and will give you ammonia. So all of these 4 will give you ammonia. Any nitride will give you ammonia. होगा क्या? ये 3 water molecules में से it will take 1 proton each to form ammonia and you will get 3 OH negative. I hope you can visualize it. Every water molecule gives it 1 proton and an OH is formed. So this will take up 3 H plus from 3 water molecules and form ammonia and you will get 3 hydrocarbons. Okay? So similarly in all these ammonia gas is released. Rest what will be formed? बाकी products भी बता सकते हैं. एल्यूमिनियम के केस में एल्यूमिनियम हाइड्रोक्साइड, मैग्नीशियम के केस में मैग्नीशियम हाइड्रोक्साइड. So we can just form the reactions. We don't have to remember everything. We can use our brains a little. और लिथियम के केस में लिथियम हाइड्रोक्साइड. ठीक है, तो दूसरा जनरल फॉर्म क्या है? एनी नाइट्राइड. एनी नाइट्राइड, ये सब एस ब्लॉक और एक एल्यूमिनियम है. एनी नाइट्राइड ऑन हाइड्रोलिसिस गिव्स यू अमोनिया. अब ऐसा कुछ दिख रहा है ऑप्शंस में? ऑप्शन बी, दिस इज एल्यूमिनियम नाइट्राइड विद वाटर. इसकी जगह कैल्शियम होता, मैग्नीशियम होता, लिथियम होता, कोई मर्जी नाइट्राइड होता, यू ऑलवेज गेट अमोनिया. तो डी गिव्स अस अमोनिया, बी गिव्स अस अमोनिया, ए गिव्स अस अमोनिया. So answer is C. The question is which does not give us ammonia, and C is the answer. Okay? So दो चीज हमने क्या सीखी? Any ammonium salt with alkali gives you ammonia. Any ammonium salt with alkali gives you ammonia. Very important. Very, very, very important. Secondly, any nitride with water gives you ammonia. Okay? अब ये जो तीसरा रिएक्शन है जिसमें अमोनिया नहीं बन रही, ये भी एक्चुअली इन टर्न इज एन इंपॉर्टेंट रिएक्शन. I want to talk about this also. तो ये हो गया डन. Let me remove this. हाँ, अब ये जो रिएक्शन है, this is a redox reaction. Important redox reaction. इसमें क्या होता है? अमोनियम सॉल्ट्स, ये भी एक जनरल रिएक्शन है, थोड़ा ज्यादा कॉम्प्लिकेटेड. एनी अमोनियम सॉल्ट विद एनी नाइट्राइट सॉल्ट. So whenever ammonium and nitrite combine, you can have any anion with ammonium, doesn't matter. You can have any cation with nitrite, doesn't matter. So whenever these two combine, this is a redox reaction. Nitrogen gas is formed. Okay? Nitrogen gas is formed. You will study about this reaction in plus 2 in great detail. But it is important to remember if you can. This will be repeated again and again. This is one of the good methods of preparation of nitrogen. Another related question is, if you have this salt, ammonium nitrite itself, this is called ammonium nitrite, ammonium plus, nitrite minus. Simply hit this, you will get N2 and the 2 water molecules. This is heating effect of ammonium nitrite. The same concept applies. Ammonium cation, nitrite ion, when they combine, they give you nitrogen. This is a redox reaction. Okay? So if they are in 2 different compounds, same thing will happen. If they are in the same compound, same thing will happen. So these are the 3 reactions about nitrogen which we studied, which are actually very important up to the end of plus 2. This is also important for JEE, and this is a very important concept. So 3 general things about nitrogen. Okay? Sure. Next. Again, bonding structures. Come on, let's do it quickly. So this is about the structures of phosphorus acids. Chemical bonding. So let's draw them quickly. H3PO4 तो हम कर चुके हैं आज. और जब ये तीनों इकट्ठे देखते हैं तो you'll get the pattern. So this is H3PO4. This is H3PO3. अब H3PO3 में क्या होता है? See, one oxygen has to be removed. So actually, instead of one OH group, you have one H group. This is the difference. So this is H3PO3. What is the third one? H3PO2. Again, one more oxygen is less, so we have 2 hydrogens now. So instead of 2 OH groups, we have 2 hydrogens. So number of pH bonds are? What are the number of pH bonds? 0, 1 and 2. So these structures are important. You have to remember them. So answer is 2, 1 and 0. 2, 1, 0. So answer is D. So this is directly from structures, and these are very important 3 structures to learn. Okay? Ciao. Next. Answer is D. This is the last question for the day. I hope you guys, many of you would be smiling if you remember it. We did it today itself. So this is kind of a test. Let's see how many of you can get it correctly. So what is formed when MnO2 is reacted with HCl? So what is the answer? Obviously, chlorine gas. So this is the preparation of chlorine gas. Directly, chlorine gas is formed. This is a laboratory preparation of Cl2, and hence when we, so what does this signify? क्या सीखे हम? ये तो ठीक है, ये तो सीख गए. सीखने की एक important चीज है. Inorganic chemistry is all about repetition. It doesn't change. तो ये मेरा लास्ट मैसेज है इनऑर्गेनिक के बारे में. जनरली +1 में पीपल आर वेरी, दे अभी सारी फिजिकल केमिस्ट्री कंप्लीट की है, इनऑर्गेनिक आ गई, ऑर्गेनिक केमिस्ट्री पढ़ रहे हैं. Many people just believe you have to remember a lot of things and you have to just mug up and mug up. That is partly true. But there is a silver lining. It is about repetition. You are doing, all of you guys are doing this for the first time. Nobody expects you to get it perfectly. Do as much as you can. It will get easier. Why? Because the same things are repeated again and again and again. With enough repetition, you can learn everything. ठीक है? You will try to begin to see patterns कि similar reactions कैसे हैं. आज मैंने काफी patterns की बात की कि कैसे हम सोच सकते हैं कुछ reactions के बारे में. It's always not about learning each and every one of them. Okay? I hope you guys get the message and are encouraged. तो people who are struggling with inorganic chemistry, thinking about अरे यार इतना सब याद कैसे करेंगे, don't fret about it. बहुत टाइम है, ये पहला एग्जाम है, बहुत एग्जाम देने हैं. क्लास 12th के एंड तक I hope you are very good by the time you are attempting JEE. Okay? Keep fighting. Don't give up. Repetition is everything. If you'll repeat it, you will surely know it. Okay? Bye bye guys. I'll see you tomorrow. Tomorrow is an important lecture, last lecture in the series. Tomorrow I will discuss some similar concepts in organic chemistry. Okay? We'll talk about some standard questions in organic chemistry and solve them. Okay? Again, these are all previous year questions. So, similar questions are asked in examinations. Okay? Keep preparing. Bye bye. Good luck.